Okay, so this is test number 2 from the series note. This test is mainly based on linear motion questions only. The last one as well I explained how these tests are going to be conducted. Right. I have to say this, there are some students who are still not taking the test. Many you are doing great, but some students who are not even taking the test. I think the reason for that is they think they will have less mark. But the thing is, that is the real situation. You need to realize that earlier. Let's say like once it is like 6 or 7 months into A levels, then there will be nothing you can do, right? So sooner you have to realize the real situation and take the steps necessary to increase your marks. Okay, so everyone has to comes. I mean, the students, especially the students who are not taking the test, you have to comes to that realization quickly, right? You cannot keep adjourning, keep postponing stuff, right? You have to take that responsibility. Okay, so okay, that's it. Then I'll move on to the first question, right? Correct sentence is about distance r. Distance cannot be negative. Distance, all right? Distance cannot be negative. Yeah. So A is correct. Distance cannot be negative because distance is a scalar. It only has a magnitude. Distance does, unlike displacement. Distance is a what? It is a scalar, right? It cannot be negative, but displacement can be negative. If the object is behind the origin, displacement is negative. So let's say this is the origin where the motion is started, right? That is origin. So if positive direction is this side, if the object moves to here and comes back here, let's say now the object is here. Now the displacement is negative, measured from the origin to the negative direction. Displacement is negative, but the distance is always adds up. This plus this. So distance cannot be negative. So A is true. Now then B, distance cannot be 0. Distance can be 0, right? If you remain at the same place without moving, then the distance is 0. So B is not correct. Distance can be 0. Distance traveled does not decrease with time. Actually, displacement decreases with time, magnitude of the disk. But distance does not decrease because distance only adds up, right? This plus this. But displacement can decrease. Let's say like you go here and comes back to somewhere here with time. So displacement has increased, now it has decreased with time. That is displacement. But the distance always adds up, right? So distance, C is correct. C is correct. Then D. Distance cannot be less than displacement. Yeah, it is true, right? Because distance always adds up. It doesn't decrease. Only displacement can decrease. The displacement and distance can be same, but same or larger. Distance is equal or larger than displacement. It cannot be less than displacement, right? That you have to understand. That is the key difference between distance and displacement. So the answer should be fourth one, right? Answer should be fourth one. Right, second question. A car moves half of its motion at 60 kilometers per hour. Half of its motion at 60 kilometers per hour. So I'll take one half as capital S, another half as capital S. So those are the two distances. So this is moved at 60 kilometers per hour. Another half is moved at 40 kilometers per hour. Right? So what they ask is average velocity. What's the equation for average velocity? You remember that, right? You might forget this because we are not using this much this that much as much, right? So average values total displacement divided by total time. Okay, so that is how we find average velocity. So total displacement is what? S plus S. Total time. So within this range, this is a constant velocity, right? From 60 to here. It changes at the other one, but within this constant velocity. So you can apply S equals ut. So according to S equals ut, time is S divided by u, right? So here the time is S divided by 60. Here the time is S divided by 40. Okay. So the sum of these two times should be the total time. Right. Then if you then you can see that S cancels off, right? You can take S off. I'll just show you the steps to the simplification. You can take S off of the denominator, then this S and this S cancels off. So you have this. So whenever you get a simplification like this, easiest thing is just multiply by the denominator here. Here the denominator, I think 120. Just multiply both by numerator and denominator by 120. Okay, so that is easy to simplify then. Remember that, right? Whenever you get a simplification like this, just multiply. So this becomes 240, 120 plus 1 over 62 plus 3. 240 divided by 5. So what is it? 5, 8. Sorry, 48. 48 kilometers per hour. 48 kilometers per hour, right? You didn't have to convert this into meters because everything is in kilometers and hours. Okay, so just 48 kilometers per hour, second answer. Another thing is when you're watching the videos, you don't have to watch the whole video, right? In the description below, the video is time-stamped, right? You will see for each question, Q1, Q2, Q3, it is linked, right? You can click that and go to the question you only need, right? You don't have to watch the whole video. You can watch only the part you want. Check that, right, in the description. And there's a written description as well in the one of those links in the description. You can check that as well. So that is a written written explanation for the problems. Remember that, right? Like in the description, it is time stamped, so you can quickly go to the question you want, right? You can only watch those questions. Third question, a bat flies towards a vertical wall. So let's say this is the vertical wall. There's this bat. So bat is a bird. So this is how the bat, his vision is very poor, right? So the bat uses sound signals to know whether there's a barrier in front of him or not. So this is regarding that. So the speed of the bat is given as 30 meters per second. Okay, so what happens? So now at this point, bat releases a sound, right? So this is for the sound, and then it, that sound is a wave. It reflects off the wall and comes back. Reflects off the, I'll just draw up here, reflects off the wall and comes back. So while this sound is moving, made by the bat also is moving towards the wall, right? Bat is moving towards the wall, the sound goes and reflects off the wall. The sound velocity is given as 330. You know that sound velocity, that is a constant velocity. It is a wave velocities. Those are constant. You will learn more about sound in waves and oscillations, right? Right. So simultaneously what happens is, as the bat moves from here to here, sound waves from here to here. Okay. Let's say for the motion of bat, time is t. Let's say tb. For the motion of sound, let's say time is ts. So both this happens simultaneously, right? So we can say time for the bat is equal to time for the sound. Right. These are constant velocities. The acceleration is not involved. So you can just apply S equals ut. So time is equal to what? S divided by u. Here we need to clarify these distances. So here the distance is, they say the bat releases a sound when the distance to the wall is 3 meters. So this is 3 meters. So in the question what they ask is, how much of a distance does the bat moves? Let's say simple d distance. Okay, if it is d, then we know that this should be 3 minus d, right? This is 3 minus d, right? Then I need to get the time for the bat. So bat moves from here to here within tb at speed 30. So distance moved by the bat is d at a speed 30. This is equal to tb. Then time for the sound. The distance traveled by sound is how much? This is 3. This distance is 3 plus 3 minus d. Then that velocity of the sound is 330. Right? Then just cancel this 2, then 11. Cross multiply. 11d equals 6 minus d. Take d to the other side, 12d equals 6. So d is equal to what? 6 divided by 12. So that is 0.5 meters, right? 0.5 meters. So this is one of the method to do this. So the principle I used is both bat and the sound do their motions within the same period, right? That happens as the bat moves from here to here, the sound goes from here to here. From here to here, right? So that happens simultaneously. That's what I just used to find what I want. So d is 0.5 meters. 0.5 meters. Still there's 2.5 meters for the bat to go. So the bat is safe right now, right? Bat doesn't collide. Now the bat notices the sound reflecting off the wall. So the bat won't collide on the wall, right? So that's how the bat notices whether there are any barriers in front of it. Right, fourth question. Two cars A and B move towards the same direction, starting from the same place, right? So we have two cars, A and B. Speed of car A 50 kilometers per hour. So you have to draw the sketches clearly. If the question is confusing, right, then you will realize what you have to do. Then B has a 60 kilometers per hour. These are constant speeds. If the car B moves after 1 hour, but the car B starts moving after 1 hour, so the car A is already moving at this speed, but then the car B starts moving after 1 hour. But since the velocity of the B is higher, as this moves, car B can catch up A somewhere here. So what they ask is starts after an hour moment. Time required for B to pass car A. So B to pass A. Let's say that time is simple t. Passing means their displacement to pass the car or anything. You need to have their at the same place at a moment, right? At the another moment it passes. So the displacement mode should be same. Whenever they say you need to pass the other one, right? First thing, you need to have this equal to be in the same position after a while. Okay. Here you can see the distances are the same. Let's say distance moved by car A is SA. Distance moved by car B is SB. Let's say like that. First, let's think about A. No, let's think about B. So it has a velocity 60. Time is just t. I took it as t. Then the car A, I'm applying ut, right? S equals ut. SA, so 50. How much of a time does car A takes to move from here to here? Car A is moving for a long time, right? Car A start moving before 1 hour. So the car A takes, if this takes simple t time, car A should take t plus 1, not minus 1, right? T plus 1 time, right? Because this car has been moving for a long time, right? More than 1 hour compared to with B, more than B. So at this speed, it moves have been moving for a long time, right? Long time is more than 1 hour. So it is t plus 1. Okay. Then 0, 0 cancels off. You need to do this cancelling off, right? When you are simplifying, you need to do this. You're not keeping unnecessary stuff as you're simplifying. Cancel everything, right? Okay, then multiply 5t plus 5 equals 60. 60 minus 5t, that is t, equals 5. I use kilometers and hours, I didn't convert. So the answer also you gain in terms of hours, right? So the answer is 5 hours. So the car B takes 5 hours to pass car A. Answer should be fourth one. Right, up to there, all the questions were based on constant velocities, right? Constant speeds and velocities. After this one, there's going to be acceleration involved. So for acceleration, you have 4 motion equations. Right. So there's this object starting at rest, and it has an acceleration 2 meters per square second. So watch how I am drawing these sketches as well, right? So everything in the question should be in the sketch if you want to draw this sketch, if the question is confusing, right? Then it gains a velocity 36 kilometers per hour. So this is in meters per second, so you need to convert this. So what do you do to convert kilometers per hour into meters per second? You multiply by 5 over 18. So you need to know this stuff, right? 1, 2, so it is 10. So what does it mean? After this acceleration, it gains this speed, velocity, 10 meters per second. Then what they ask is distance traveled. and the speed is achieved. There's a problem with that question, right? It should be time it takes, right? There's a problem with the question. It should be time it takes and distance it traveled. Okay. It should be time it takes and distance it traveled. Right. First I'll find time it took. So final velocity 10, initial 0, acceleration 2, time is t. Then divide by 2 both sides. So you get 5 seconds there. Then in order to find distance, half at squared, u is 0, right? So ut term cancels off. Acceleration 2, time is, I just found it, 5 squared. 2 cancels off, so it is 25 meters. So the distance it traveled is 25 meters and time it took is 5 seconds. 5 seconds and 25 meters, so fourth one answer. Right, then sixth question. An airplane should have velocity 50 meters per to fly, right? So it starts to lift at 50 meters per second. If the runway of airport is 500 meter long, required acceleration of the airplane. So they are, let's say the airplane here is at rest, right? Here the airplane is at rest. It needs a speed 50 meters per second. So it will start lifting up from this point. But it takes a distance in order to gain this speed, right? At once it cannot gain that speed. So what they ask is the acceleration required for this. So time is not involved, so you can use this equation. So final velocity 50, initial 0 plus 2a, distance is 500. This is 2500. This is 2 times 500 means 1000, right? Then divide by 1000 both sides. So it is 2.5 meters per square second. So that's the acceleration. Got it? That's the acceleration. Third one answer. Right, seventh question. When a car moves a distance 75 meters, its velocity decreases from 30 meters per second to 15 meters per second. Right? Then the car further moves the distance s and comes to rest. So what they ask is this distance. How do you find that? So you can see the speed has decreased, right? So there's a deceleration, obviously. Then finally the car is losing its velocity. Then it stops here. So there's a deceleration. First thing you have to find that deceleration. Let's say 1, 2, 3. So these points. So I'll apply equation from 1 to 2. Because there's no time involved here, you can use this equation. So final velocity 15, initial 30 plus 2a, distance is 75. So 15 is 225, this is 900 plus 2 times 75, 150 acceleration. So this is 900 plus 225. So it is 700, 675, right? Is equal to 150 acceleration. Just let's divide by 10. Then we'll divide by 15 at once. 67 divided by 15. So it has 4, meaning 60. 7 is remaining. 75, how many 15s? 5 15s. So this is minus 4.5 meters per square second. So that's the deceleration, right? Just the deceleration. That is not what they ask. What they ask is this distance. Before it stops, how further it moves. In this region as well, we have the same deceleration, right? This region as well. Again, you have to apply this equation. So that is applied from 2 to 3. Final velocity here is 0. Initial velocity here, right? 15 squared plus 2. Acceleration, this I'm applying this equation to this side. Acceleration to the other side. It's the deceleration. So you can say minus 4.5 s. 4.5 times 2 is 9. Minus 9s. Take it to the other side. So it becomes 9s equals 15 squared is 225. Then divide both sides by 9. So you have 22 has 2 9s. 4 is remaining. 45 has 5 9s. Right? So that S is 25 meters. S is 25 meters. That's the answer. Fourth one. Right. Next question. 8th question. Reaction time. So that question is based on a reaction time, right? So that reaction time thing is you clearly have to understand what reaction time is, right? I think they have asked questions on that. They have misunderstood this one, reaction time. Right. Okay. So there is this driver. You have this driver there. And suddenly he notices a wall in front of him. As he notices the wall, he's been moving at 20 meters per second. He suddenly cannot stop the car, right? He notices the wall. He suddenly cannot stop the car. So the moment he notices it, what does he start to do? He starts to paddle the brake. And those signals goes to the brain and it causes a reaction. Then finally he applies the brake. So for that it takes time. Still the brake is not applied, right? For the signals to go inside the brain and to cause a reaction, it takes time, right? While that is happening, it taking a time, they say it takes a time about 0.5 seconds, I think. Yeah, it takes 0.5 seconds. Here the brake is not applied. So what happens to the car? Still moving at 20 meters per second. Still moving at 20 meters per second. So this range is what we call reaction time. So remember that within the reaction time, the brake is not applied. The brake is only applied after the reaction time, right? So this is the time it took for the reaction of the driver, right? After this time, then it starts to decelerate due to the brakes. Then deceleration is given as 5 meters per square second. So in order to prevent the accident, so the car has to just move to here and it stops. So what they ask is, what should be the distance? This total distance is what they ask. From here to here. So this is 1, 2, 3. So you need to find this distance. That's a constant velocity. Within the reaction time, it is moving at constant velocity. So you apply S equals ut. Speed is 20, time is 0.5. So this is 10. 0.5 means half, right? So within the reaction time, it is move towards the wall 10 meters. Okay, 10 meters. Then just apply from 2 to 3. There's a deceleration. Deceleration starts within that. How can we find that? So the initial velocity is 20. Velocity here should be 0. You can apply this equation. No time involved. Final velocity is 0. Initial one 20 squared plus 2 times acceleration, actual deceleration. So minus 5 s. 2 times 5 is 10. So minus 10 goes to the other side. Plus 10s equals 400. So s is 40. Let's say this is S1, this is S2. Distance from here to here is 10 meters. Distance from here to here is 40 meters. So just have to add these two to get the answer. So that total distance is the answer. That is 40 plus 10, it is 50 meters, right? Third one is the answer. Right, ninth question. A car and a bus starts moving simultaneously. Simultaneously means at the same time. And their accelerations 6 and 4. Initially, car is behind 100 meters. The bus is here. So car is behind 100 meters. Their initial velocities are 0, right? They just starts moving simultaneously. Car has a acceleration 6 meters per square second. Bus has a acceleration 4 meters per square second. So the bus is in front of 100 meters, but the car has a higher acceleration. What they ask is time required for the car to pass bus. Right. So bus is moving like this. The car starts to move. And somewhere here, the car can pass the bus because this has a higher acceleration, right? Let's say that time is simple t. For this one as well, time is simple t because this is happening simultaneously. The distances, initial positions are different, but the whole thing happens simultaneously, not after or before time. The displacements are different. Actually, what they ask is time, right? Time. So you need to have a combination between these two cases. What can you say? So bus moves from here to here. So we can say distance by bus. Distance by bus plus 100 meter. Distance moved by bus plus 100 meter is equal to what? Distance by car. Got it? Distance by car. Since this has accelerations, you cannot apply ut, right? What do you have to apply? Ut plus half at square. Because there's acceleration here. So for both cases, initial velocity is 0. So I'm getting rid of that. So you can apply half at squared. Okay, for the bus, let's apply that half acceleration 4 t squared plus 100 equals for the car half acceleration 6 time is t. Okay, 2 t squared plus 100 equals 3 t squared. Take it to the other side. 3t squared minus 2t squared. So it is t squared. Take the root. So t is equal to 10. Okay. Is it 10 seconds? Yeah, it is just 10 seconds, right? The car quickly passes the bus, even though it is 100 meters, right? So it only take 10 seconds for the car. Fourth answer. Right. 10th question. An object at rest starts moving under constant acceleration. At rest, starts moving at constant acceleration. Within the 5th second of its motion, it moves a distance 90 meters. So this concept you have to understand what within means, right? Not after. It's not after 5th second. It is within 5th second. So we are talking about motion within a 1 second. 5th second means 5th second and 4th moment, 4th second. 5th second means that one. What is 1st second? 1st second means t equals 0 and t equals 1. 2nd second means t equals 1 and t equals 2. So 5th second should be t equals 4 and t equals 5. Just one before that, right? That within means that. So within that, they say it moves a distance 90 meters. Then what they ask is velocity of the object at end of the 5th second. End of the 5th second means here. Let's say that velocity is v. Okay. Right. So those are the details given. Since this has acceleration, first thing you need to know the acceleration. Without knowing that, it is hard to find v, right? So first I'll use so let's say from here to here the distance is s1. From here to here distance is s2. I need to involve this 90 meters, right? That's why. So s1 minus s2 is equal to 90. So the equation you have to use is this one because there's acceleration. Ut is 0, right? Because for both cases they are starting at not both cases, because it starts at 0. Okay, so for s1, what do you have? Half acceleration a, time is from here to here, time is 5 seconds. From here to here, time is 4 seconds. Right. So I'll take halfway out, right? Within brackets, you have 5 squared, that is 25, 4 squared, 16, 90. 25 minus 16 is 9 actually. So this 9 and this one cancels off. This 2 goes to the other side. So A is 20. So that is a large acceleration, right? 20. Acceleration is 20. Okay, now we found that we need to find v. So just apply v equals u plus at from here to here. U is 0, acceleration 20. Time they have given us, this is 5th moment, right? 5. So the answer is 100 meters per second. 4th one is the answer there. Right. Then 11th question. I think after this, all the questions are regarding gravitational acceleration, right? Okay, 11th question. ball is released from a building and it takes 8 seconds to hit the ground. Velocity it hits the ground and height of the building is height of the building h, and they ask v. You know the gravitational acceleration, that is 10 meters per square second downwards. You just apply this equation to find the velocity. Initial 0, 10, right? Because I'm applying equation downwards and the acceleration also downwards. So 10, time is 8. So this is 80 meters per second. That's the velocity it hits the ground. Then you need h. So for this equation downwards, h is this one, half 10, t means 8 squared. So 8 squared 64 divided by 2, 32, 320 meters. So the height of the building is 320 meters. So it only takes 8 seconds to land on the ground. Okay, so that's an easy question. So the answer should be 80 and 320. So first one, right? First one is the answer, right? Then 13th question. An object at rest starts moving down. Distance it traveled within the nth second. So distance within the nth second means, let's say this is t equals n second. Within the nth second means within n minus 1 and n, right? Remember that fifth second earlier question, fifth second means 4 and 5. So n second should mean n minus 1 and n. So what they ask is this distance. Okay, so initial velocity 0, it is just released, right? So we need to find this distance. So how do we find that? Same case as before. This distance s1 from here to here. This distance s2. Initial velocity 0, right? So you can use half at squared. Ut becomes 0 for s1. Half acceleration g, time is n, right? From here to here time is n. Then s2 is half g, from here to here time is n minus 1. Then what is s1 minus s2? Half gn squared minus half g n minus 1 squared. So these are two terms, you can take half g out. So within brackets it is n squared minus n minus 1 squared. Half g n squared minus n minus 1 squared means n squared. So this is a plus b squared, right? B squared plus 2ab. So this is n squared plus 1 minus 2n. N squared minus n squared cancels off. Minus minus plus 2n minus 1. Right? So this is the distance it traveled within the nth second. Within the nth second means just a 1 second. Within a 1 second. That is n minus 1 and n. So after that it is a simple algebraic simplification, right? The answer is fourth one for that. Fourth one. Right, 13th question. A man with a parachute free fall for 10 seconds and he falls to the ground with deceleration 5 meters per second with it another 16 seconds. Height he dropped from the plane is. So let's say he's dropped from the plane here. Dropped means initial velocity 0. Free falls means he's moving down at 10 meters per square second. So gravitational acceleration, free falls. So this happens for 10 seconds. From here to here, he hasn't launched the parachute, right? So let's say from 1 to 2. After that, he launches the parachute. Then he starts to decelerate. Then the acceleration upwards, meaning decelerates 5 meters per second. So what they ask is, what's the speed? Is it the speed? No, the height. What they ask is height, right? So this is the two-part question. You have to solve from here to here for this acceleration. Then from here to here for this acceleration. This is actually deceleration. You cannot apply equations from here to here, okay? Because these ranges have two different accelerations. Right. So for the I'll first do from 1 to 2. What do we have? We have initial velocity, acceleration and time. Just let's say that is S1. Let's say this distance S2. So it is ut plus half at squared. Initial velocity 0. We don't need the final velocity. Plus half, acceleration 10. Time is 10 seconds, right? So this is 5 times 100, 500. So S1 is 500 meters. That's the distance from here to here. That is 500 meters. Then we need to do this kind of like the same thing for here. From 2 to 3. But before that, you need to find velocity here. Let's say u. Because I am going to apply the same equation. There can be other ways as well, right? Okay. You can follow any of those methods as long as you are substituting the equations and correctly, right? And you are dealing with vectors correctly. But here I'm using this. So at here I need to find u. So for that, from 1 to 2 I'll apply v equals u plus at. So I put it here as u, that's the final velocity. Initial velocity is 0 plus acceleration 10 from 1 to 2, right? Acceleration 10. Time is 10 seconds. So we have 100. U is 100 meters per second. So we just found velocity here, 100 meters per second, which will be useful to find this distance. Right, then I'll apply equations from 2 to 3. I'll just apply here, 2 to 3. Same equation. That is S2, initial velocity 100. I'm applying downwards, right? Initial velocity 100, downwards. Time is it given? It is given. This time from here to here is 16 seconds, right? 16 plus half. What's this acceleration? It's a deceleration, right? Because a parachute has to decelerate. Otherwise, the man would collapse on the ground and die, right? But once the parachute launches, it has to decelerate. It has to decrease its speed, right? So I'm applying the equation downwards, but the acceleration is upwards, meaning deceleration. So here you have a minus 5. You have to substitute as minus, right? Time is 16 squared. 16, its guess is squared. Let's simplify this. So this 1600, this is minus. This is 16 squared means 256. 256 divided by 2, 128 times 5, right? 256 divided by 2, 256 divided by 2, 1, 2, 128. Then multiply by 5. So 1600 minus 0, 4, 4, 6, 960. So 600, get rid of 600, then get rid of another 40. 960 meters, yeah. So this is S2. So S1 is 500, S2 is 960. We have to add both in order to get the total distance he fell 0, 6, 14. So 1460 meters he falls down. Fifth one is the answer there. Right. Then 14th question. A stone is released from top of a tower. It moves 25 meters at its last second of motion, meaning before it collides with the floor, right? Let's say it collides at time t. Last second means t and t minus 1. It moves 25 meters. So what they ask is height of the tower. Height of the tower means from here to here. Let's say capital H. So we already have done like 2 questions from this type. Initial velocity is 0 because it is dropped, right? When you drop something, initial velocity is 0, right? If you throw something downwards, then there's an initial velocity. But if you drop something, meaning it is released. Okay, from here to here, let's say the distance is S1. From here to here, let's say distance is S2. Then this S1 minus S2 is equal to 25, right? Initial velocity is 0, so ut is 0. So you can get half from here to here, acceleration 10, time is t, minus half. Sorry. So st, the half, acceleration 10, time is t minus 1. From here to here, time is t minus 1 squared is equal to 25. So I can cancel this 5, this one 5, divide the whole thing by 5. So you get t squared minus t minus 1 squared equals 5 when you divide the whole thing by 5. So this is t squared minus 2t plus 1. T squared cancels off. 2t minus 1 equals 5. Then take it to the other side, plus 1, 2t. 5 plus 1 is 6. 6 divided by 2. What is it? 3. 3 seconds, right? So we now have a value for the time for the object to reach from here to here. So that is what we needed, right? For the object to reach from here to here. So if you know that, you can simplify into S1, which is the height of the building. 10 T square is 3 square. So I have 5 times 9, that is 45, right? So the height of the tower is 45 meters. Okay, height of the tower is 45 meters. First one is the answer, right? So let's say like you are on top of a tower or like a building, right? If you release an stone from top of the building and you have a watch, right? You release it. You know, as it hits the ground, you hear a sound, right? You switch on the clock, then switch off the, stop the time once it hits the ground, right? Let's say it reads as like 3 seconds. 3 seconds. Then you can apply this equation in order to find the height of the building. Time is 3 seconds. So it is 45 meters. Got it? You can find the height of any building or like a tower, but you have to go up to that. Then you can release a stone or something, right? You just have to measure the time it takes for that stone to hit the ground. Okay, just try that when you are on a building, right? Right. So then there is this question, 15th question. It is somewhat a creative question, right? A mango falls from top of a tree. So let's say this is the tree. Okay. So you are inside the home, and you are looking out of the window. Height of the window is 2.4 meters. And they say it takes 0.4 seconds. So as you are observing through the window, you see a mango moves from here to here. So it is visible for 0.4 seconds. So that happens within 0.4 seconds. And they say top edge of the window is at a 3 meter. At a 3 meter. So this is all you observe. So what they ask is, now these are given, right? Or you measured these. So using these details, you need to measure the height of the mango tree, right? You have to measure the height of the mango tree. So for that, you need to do the calculation. So these are practical cases, right? Practically you can do that, but you need to measure this time. It is somewhat difficult, right? Measuring this time, 0.4 seconds. It's a small time. Okay, so you might need like electronic apparatus or something to do something like that. Okay, anyway, so we know that gravitational acceleration, that is 10 meters per square second downwards. I'll say here the t is 0, time is 0. That is where the mango was, right? For the mango to reach from here to here, let's say time is t. At the lower edge of the window, what's the time? If it is t here, it has spent 0.4. So the time should be t plus 0.4. Here t plus 0.4. Here t. Okay? Right. I think we have to find time, right? This time, this t. There are other ways also to do this, right? But I'm choosing this method. Okay. So we know somewhat like everything from here to here. So I'll apply this equation. I think it could work. Yeah. Before applying that, you need to know velocity here. Let's say that velocity v1 and the velocity at the lower edge of the window. So you have to apply v equals u plus 80, right? So if you apply that one, velocity here becomes gt1. Sorry, gt. Because u is 0. Initial velocity is 0, then g time taken is t. Then likewise here velocity, initial velocity, when you apply equation from here to here to here, equation should be gt plus 1. Obviously acceleration is g, then time is t, right? So you can find velocity at each cases. Okay, now we know within this range, we know the initial velocity and the final velocity within this range. Then just substitute those. G, u is gt, this velocity g, t plus 1. What is the time from here to here? Time is 0.4 seconds, right? Divide by 2. And then this distance is given as 2.4. Okay. Then I'll just divide 0.2. 0.2, this becomes 12. If you divide 2.4 by 0.2, 24 divided by 2, that is 12. So 12 is equal to, this is g means 10, right? So you can substitute that 10t plus 10t plus 1. Then you can, if you want, you can divide the whole thing by 10. So this becomes 1.2 t plus 1. So tt becomes 2t plus 1 equals 1.2. So 2t equals 1.2 minus 1, 0.2. Then t is equal to 0.1 seconds. Okay, now we found the time there, 0.1 seconds. There's a mistake here, right? This time is not t plus 1, it should be t plus 0.4, okay? Get it? 0.4, not plus 1. Not plus 1, right? Time is t plus 0.4. Then divide the whole thing by 10. So this becomes 1.2 t plus 0.4. This is 2t. 1.2 minus 0.4, 0.8. Divide by 2, 0.4 seconds. Now we found the time, that is 0.4 seconds. That's the time for the mango to reach from here to here. That is 0.4 seconds. Okay. Right. So if you know that time, that is all we need. So you can find this distance. Let's say that distance is s1. Simply apply this equation downwards. So s1 equals initial velocity 0, half 10, time is 0.4 squared. So you have 5. This is 0.16. So that is 80. 0.8 meters. One distance is 0.8. So we know this distance, 0.8 meters, right? Then this distance is what? That is 3 meters. This is the distance to the top edge of the window. Then this distance is 0.8. So the whole distance should be 0.8 3.8. So 3.8 meters is the height of the mango tree. 3.8. Got it? There can be other ways as well to solve this problem, right? You can feel free to choose any of the methods, right? If you substitute correct values and correctly use the equations within the correct time periods, then at the end you will get the same answer, 3.8 meters, right? But kind of like you have to break it down the question somewhat some way like this, right? You don't need to have the exact same method. Okay, right? So that's all the questions, right?